Hi everyone, in this video I will show you how to prepare the circuit of a full wave rectifier and carry out the experiment for calculating the ripple factor of this full wave bridge rectifier. So first we will do the circuit preparation. For preparing the circuit, from here we will take a AC voltage source and set it to 20 volt and 10 hertz. Now we will require 4 PN junction diode. So let's bring from here. This one is the first one. This is the second one. Sorry. So this is the wrong one actually. So this is the second PN junction diode. This is the third one. And lastly this is the fourth one. So our 4 diodes are ready. Now we need to connect these 4 diodes. So from here we will connect to this diode. And from this end we will connect to this diode. From here we will do the connection to this point, and from here we will do the connection to this point. Now just connect this AC power supply to this point and the other side to this point here. So this is the circuit using the 4 diodes. So, set all these diodes to 1 and 4001. So now all 4 diodes are 1 and 4001. Now we need a load resistance. So from here you bring this load resistance, just rotate it out, set it to 1 mega ohm, and then connect it into this supply, into this circuit. Connect the other end to this point. So now it's done. Now we need to take a multimeter and an oscilloscope. So multimeter is used to record this voltage across this load resistance in terms of AC as well as in DC, and oscilloscope is used to record the output signal. So from here you can take this multimeter, connect one end of this multimeter to this point and the other end to this point. So now this multimeter is connected. We will bring one oscilloscope from here and connect this channel A to this point. We need also to earth this oscilloscope, so bring the earth from here, and from this trigger point just do the earthing. The circuit earthing is also required, so we will bring another earth and connect it at this point. So our circuit is now completely ready for carrying out the experiment. For getting the ripple factor, we need to vary this voltage within the breakdown voltage of the diode, which is 50 volt, and record the output DC and AC. The ratio of the output AC to DC will give out the ripple factor. So let's switch on the circuit. So this is the multimeter. Now from here when I switch on the circuit, I am getting this kind of output voltage. This is the output signal which we have got. So it converts the entire DC into a AC signal. From here we will take the DC output, and by clicking at this point we will get the AC output, and then we will vary this voltage to, let's say, 15 volt, and again switch on the circuit. We will get another output signal, and then record its DC as well as AC voltage. Similarly we will again change it to 35 and get the output. So 5 to 6 observations we will take in terms of both AC and DC output. For each of the observation we will take the ratio of AC to DC and find out the ripple factor. Then we will take the average, and that average will give us a value of ripple factor which is close to 0.48. So that's all for this video. Thanks for watching this video. Please do like, share and subscribe.